Welcome to Mrs. Bibb's Math Class Week 9. Please make sure to fill in your table of contents. Complete your warm-ups for the week. And the first thing that I have here is just a review. You do not necessarily have to get these student journal pages. If you can't mentally give a definition of these, or a semblance of a definition of these, then please look them up on pages 36 through 100, then please look them up on pages 136 to 140 and read those definitions. These are definitely things you need to know. And you definitely need to know when you hear slope-intercept form, y equals mx plus b. So please make sure to look that up. We're just talking about linear functions here. Well, not all of these are linear functions. When you're referring to slope, there are three ways to describe slope: positive slope, rising to the right; negative slope, falling to the right or rising to the left; slope of 0 is a horizontal line; an undefined slope is a vertical line. Of all four of these, only three of them are functions, and that would be these three because they would fail the that would be these three because they would pass the vertical line test. This one is not a function because it would fail the vertical line test. Still review for this next one. When we're looking at this, still review here. When we're looking at this, it shows us slope-intercept form. It shows you where the intercept is. The intercept is an ordered pair, 0b. And then the slope, of course, is your rise over run. This one has negative slope. So that's just the end of a quick review of slope-intercept form and those words of slope, y-intercept, that you need to remember. For the next part, you will need a calculator to fill in these two tables. This table you don't need a calculator for. It says y equals t. So I'm just going to put those values. They're the same value, y equals t. Whatever t is, y is. So I'm going to fill in that table. Then if you will get a calculator, you're going to do 2 to the 0 minus 1, which that one you may be able to do. Anything to the 0 power is 1. 1 minus 1 is 0. Okay, so I used a calculator to find those answers. Now what you need to do is plot these ordered pairs, 0, 0, 0 0.2, 0 0.2, 0 0.4, 0 0.4. Plot all of these ordered pairs and then draw your graphs. Here's my graph. You want to make sure to label each one. Here is your y equals t, that's your linear graph. Here is your y equals 2 to the t minus 1, that's your exponential graph. Then here's your y equals t squared, that's your quadratic graph. Average rate of change, and you have heard rate of change for years now when talking about linear functions. It has to have a constant rate of change in order for it to be a linear function. One thing I want to point out though, you're going to know it's a linear function if the first differences are constant. If the first differences are not constant, then you can see if the second differences are constant. If the second differences are constant, then you will know you have a quadratic function. Now, if neither of them are constant, you can check the ratios, and you could actually check the ratios before you check a linear function. If neither of them are constant, then check to see if consecutive y values have a common ratio, which means when you make them into a fraction, will they reduce into the same value? And here's one good thing to point out. No matter which of those three scenarios you're thinking about that you may have, in all of those cases, the difference of consecutive x values needs to be constant also. Then there's some facts here on Student Journal 273 that you need to think about and know. Both of these pieces of information, and just know those facts. I think it's easy to tell from the graphs themselves that those facts are true. The next group, you're going to plot the points. You'll have to make your own x and y axis, and then you will have to tell whether they appear to represent a linear, an exponential, or a quadratic function. Here are the answers to 1, 2, 3, and 4. For 1, when you plotted those points, made your x and y axis, when you plotted those points, hopefully you can see that this makes that U shape that is characteristic of a quadratic. And so this one is a quadratic. For number 2, when you graphed, hopefully you can see it's not a full U shape, and these things are increasing exponentially. Then for number 3, as you look at these, and I did not cut out the answer, this is also increasing exponentially, but in the reverse direction. And then the last one, hopefully you can see that this is a straight line. So these are linear. When I look at 5 and 6, I need to look at the constant difference. Actually, I'm going to think about the fact if I have a ratio or not. I know it's going to be exponential if there's a common ratio. So when I look at this, 4 divided by 7, 1 divided by 4, would that be a constant ratio? No, those are not the same. So number 5 is not exponential. Let's see if it is linear. So number 5 is a linear function. 2 minus 6 is negative 4. 0 minus 2 is negative 2. 2 minus 0 is 2, and 6 minus 2 is 4. So that's not a constant rate of change. Do let me look and see, though, if this is going to be exponential. 2 divided by 6, is that going to be the same as 0 divided by 2? No, so number 6 is not exponential either. Now let's do the next differences. Negative 2 minus negative 4. That's positive 2. The textbook says that this is quadratic. To be a quadratic, the second differences are constant. And my second differences are not constant, which means these numbers should all be the same. I think this is none. Let's look at number 7. I believe for number 7, what I would do is make myself a table. Make sure that my x's are a constant rate of change, which they are, even up here they are. And then I would do my differences. First, I would check for my ratios. Negative 1 divided by negative 4 is 1/4. Is that the same thing as 2 divided by negative 1? No, so it's not exponential. Okay, let's look at my first differences. Is the first differences are constant, so this is a linear function. For number 8, I'm going to make myself a table again. Check my ratio, 0 divided by negative 9. that the same thing as 3 divided by 0? No, you can't divide by 0. So that's not an exponential. The first differences, and that's not a constant rate of change, the first differences. So let's do 3 minus 9. My second differences are constant, therefore this is a quadratic. I don't know what happened here. If you see what I did wrong, please let me know. I just do not see it, and I looked at that for quite a while. A ball is dropped from a height of 305 feet. The table shows the height, h in feet, and the ball t seconds after being dropped. Let the time represent the independent variable. Tell whether the data can be modeled by a linear, exponential, or a quadratic function. Okay, so let's look at the ratios first. 289 divided by 305, is that going to be the same thing as 241 divided by 289? I'm pretty sure we can all see without much effort that there's no way this fraction would reduce and be the same as this fraction. So it's not exponential. And as you can see, I did 289 minus 305, 241 minus 289, 161 minus 241, 49 minus 161. This was not a constant rate of change. So then the next thing that I did was I did the second differences, negative 48 minus negative 16, so on and so forth, and I did get a constant number. So this one, number 9, is a quadratic. And how would you explain? You would explain by saying quadratic. This is a quadratic because the second differences are a constant rate of change. That's it. I hope you've had a great week.